and welcome. Today I'll be sharing my solution for the IMO 2022 problem 2. Now the thing I want you guys to know is that this problem has a lot of solutions which are basically almost the same. They are not very different. If you go on art of problem solving or in fact if you have a look at the official solutions, they are almost the same. They all do not have they all converge, like the main ideas are the same, which I did not find that intuitive. So today I'll share my solution, which I'll try to explain the motivation and the intuition behind my ideas, which hopefully you guys find it which makes much more hopefully it will make much more sense and which will appeal your intuition more. So yeah, and I can say that yeah, the majority of the ideas are unique. They are not based on the official solutions. Although some part of the, like when we'll solve the problem, the beginning of the solution will slightly be similar to the official solution. But that is the idea for the initial steps, like the initial solution, the initial basic steps when we'll write the solution. Those ideas are quite, I would not say as very trivial, but yes, they are trivial to some extent because majority of people who are have solved inequalities and all will, yeah, they will know that they'll eventually get to the first step. So okay, so this will make much more sense if I write the solution. So now, before let us first understand the problem. Like, let's just have a look at the problem. Okay. So like every inequality problem says there are positive real numbers. Okay. Yeah. So there are positive real numbers, and there is a constraint on those real numbers, and we have to show something. So show a particular statement. Okay. That is how basically this inequality works. But that the one more thing here is this is something which we have to keep in mind. So this is something which we'll have to use somehow. This and all is a standard format for inequality problems. Now the first troublesome thing, or the first rock which you can see while attempting the problem, is this ugly term here. So this ugly term is actually which we'll have to remove first of all. So we'll have to reduce this statement into we have to prove an alternate statement. If we prove that alternate statement, we'll get this statement for free. So that is a strategy which we'll use because this thing is very difficult to deal with. We can't really don't have basically you cannot directly prove this. You can maybe, but I don't see a way because it's very you don't have that many don't have we don't have intuition on working with these kind of terms. So in fact, if you have solved a lot of inequality problems based on AMGM, you'll immediately the first idea that will strike you is you have to use weighted AMGM. Yes, because these kind of terms are very common when you uh, solve weighted AMGM problems. Now, if you don't know what weighted AMGM is, no worries. If I'll try to uh, uh, show that this thing, yeah, this thing I'll try to use normal AMGM and try to get it into the normal, like the another equivalent statement which I said in the said before a while ago. We'll try to reduce it into that. So okay, so the thing is, let's analyze this term here. This term is a to the a, b to the b, c to the c. If you look at it, we can look at it this way. So this is nothing but, I'll use a color here. Okay, let me just write it like this. This is nothing but a into a dot 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 a. Then we have into b into d dot 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 b into c into, okay, let me change the color. So okay, c into c into c dot 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 c. Then we have into d dot 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 d. So a is being multiplied with itself a times. So this is a times. Then b is being multiplied with itself b times. And then c is being multiplied with itself c times. Similarly for D, D is being multiplied with itself D times. Now recall if we had AMGM. So what does AMGM say? That if you have n terms, okay, let's say you have positive real numbers and there are n of those real numbers. Let's say for the sake of for simplicity, let's say they are a1, a2, an. So there are total of n real numbers. Okay, so if you have n real numbers, these are not necessarily uh, they are not necessarily distinct, so they can be equal to each other as well. There is no constraint on, yeah, there is no where written in the official any AMGM statement that they have to be distinct. So AMGM says is what AMGM says is that if you have n of these real numbers, okay, if you have these n of these real numbers, what AMGM says is basically if you sum up all these real numbers and divide them by the total number of such numbers, in this case which is n, this should be strictly greater than or equal to the nth root of the product of these all numbers. Okay, so this is what AMGM says, and this is where we are going. Then we are going to look at this term here in this manner, in a slightly uh, more sophisticated way. So let's see. The thing here is, here we have n, right? Here, if you notice, what is our the first job in order to use AMGM for this thing is we have to find our n. So here our n can be a plus b plus c plus dy, because if you notice there are a terms here, right? B terms here and c terms here and d terms here. So in total there are a plus b plus c plus d terms, and we'll use AMGM for that. So okay. So now we have realized that they are a plus b plus c plus d. So our n is a plus b plus c plus d in this thing. So um, what I can say is that a into a plus b into b plus c into c plus d into d by a plus b plus c plus d is greater than or equal to the root of a plus b plus c plus d, a to the a, b to the b, c to the c, d to the d. What is this? So a is being multiplied a times, right? So it is in, if you go on to the arithmetic mean side, you will have that a plus a plus a times. So that is basically a into a. So this you can look at it this way. You can look at it this way. This is a total of a times, right? That is what this means. Similarly for b, similarly for c, and similarly for d. So this is basically AMGM. So yeah, so this is how we have used AMGM in this particular way. So what this means is, now the thing is, it's much nice because it looks nice because we have a plus b plus c d plus d on both sides, right? This is nothing but one. This is nothing but one. So what I essentially have is sigma a square. Okay, so nothing but a square plus b square plus c square plus d square is greater than or equal to a to the a, b to the b, c to the c. Now this is nice because now we can actually reduce this problem into another instead of proving this statement, we'll prove uh, another statement which will give this statement for free. Okay, so if I show if so basically now it suffices to show this. Sorry, there is a strict inequality here. Yeah. Now the thing is, if I show this, I will get this original statement in the problem for free. How? Because of this simple thing which we have shown here. So basically you can replace this by this term here, like this term, entire thing is greater than or equal to this term. So you will get that for free. I hope you can make sense. I hope you can understand why we are trying to show this. This is much more, the motivation is that this is much more easier to work with than this ugly thing. So we'll work with this. Now the one more good practice in dealing with algebraic expressions is that you make it homogenize on both sides. This is also a standard trick or technique, whatever you want it to be. So yeah, so this is actually, if you have, you can see a degree 3 terms here, but we have only a constant term. So is there a way we can homogenize on both sides? And yes, in fact there is. You can write this one as sigma a whole cube. So what we want to show now is essentially this. So from now on, I'll try to use the sigma notation because these are long expressions. So that takes up much more space and time to write them out. Now, the first thing when I saw this expression was, so this still here, the official solution, this part of these, the steps which you have written till now, these are exactly the same. These overlap with the official solution given by IMO as well, and on other places. Now we'll slightly diverge our ideas. Now the thing is, the first thing uh, when I saw this was, the thing which I observed was, it would be much, see, I have four variables on both sides, right? So is there a way to get somehow three variables on one side, maybe, which would probably simplify? It's a potential, maybe it can potentially simplify things. So that was my first thought. Now the thing was, yes, I do have a constraint on a plus, on a b c d and d. So perhaps if I use this intelligently, I can somehow simplify the problem a bit. And immediately I got an idea that, okay, so this thing here, okay, so yeah, so this thing we can actually write it like this, right? So what I'm trying to get at is this. So we can actually write this as, so this thing is nothing but one. Okay. So yeah, so this are the yeah, okay. So this thing I can write it as, yeah. So this is what we can write it as. Now if you notice, yes, I have eliminated basically a here. So instead of a, I only have b plus 2 plus b plus 2c plus 3d and a constant. So let's use this thing here. Maybe we will get somewhere. Let's see. So that was my basic. I thought this kind of experimentation seemed to be making some. This kind was, maybe this was a potential. Maybe this could create some sort of a breakthrough. So I experimented with this, and eventually that led to some other thing. So let's see what happens if I put it here. So what I'll get is sigma I square. So what we want to show is now that sigma I square plus sigma I square into b plus 2c plus 3d is less than this thing. Now instead of writing it as a plus b plus c plus d whole cube, the thing I wanted to note was that I have a sigma I square on the LHS, right? Is there any way I can create sigma I square on the RHS so that comparison becomes even more easier? And instead of, so the one of the ways that just you bash and you expand a plus b plus c plus d whole cube entirely, but that was not really smart. So I refrained from that. So I thought, yeah, you can actually create a sigma I square on the RHS itself, and it's very standard. So let's say I write this RHS term like this. So what I've written is basically a plus b plus c plus d whole cube is what I've written is a plus b plus c plus d whole cube is a plus b plus c plus d into a plus b plus c plus d whole square, which is basically this part. This part is basically this part. So that's what I have written here. And now the thing is, we are getting actually some sort of cancellation, which is nice. So what the terms which will cancel is this term and this, the product of these two terms. So these are getting cancelled. So what I'll be left with is this. Okay, so this is what we have been left with. This is what we want to show. The thing is, I don't want to. Don't write this a as again a of sigma is as one, because you have a two second degree term here and you have a 3 degree term. For the sake of comparison, let us not write sigma as equal to one. Let's compare it like this, because then we have homogenization on both sides, right? Okay. Now the next thing which was quite annoying was, basically, if you look at the LHS, you have three terms, but their coefficients are not all the same. They are like 1, 2, and 3. So is there any way, I thought it would make it much look nicer and much more easier for comparison, like much more easier for finding inequalities, is that the actual idea was, okay, can I make the coefficients equal using some sort of information or any tool? And after looking for a bit, I found that, okay, we have not used this thing in the problem, right? We have not used this thing. So, and after looking at this and that, I immediately realized that, okay, I have d is less than equal to b. So what this would mean is that b plus 2c plus 2d plus d is less than equal to b plus 2c plus 2d less than b, which is nothing but your this. So this is much nicer. So what I've done is I've sent d to b. That is how you can pictorially think it of. Like that's the imagery which comes in the mind, sort of interpretation. So this is what you get at. This is what you. So this is what essentially what you've gotten is that b plus 2c plus 3d is less than or equal to 2 into b plus c plus d. Now this is because b is less than or equal to d from the problem statement. Now the one thing that I want is that now I have b plus c plus d. Now this I want to get b plus c plus d on the, if you look at this inequality, which this is what we had to show. Now on the RHS, I somehow want to get b plus c plus d. Why? Because I have this tool. I want to use this tool somewhere. I cannot directly use it on the LHS, because that would not, because there is a bound like this, and these are the same sign. So not really helping that much. I cannot use it directly on the LHS, but maybe if I could do something on the RHS, then that would create some way to incorporate this fact. Maybe that's what I was thinking. So, and then I realized, okay, let's look at this thing here, sigma AB. May I notice this? So I noticed that sigma AB is AB plus BC plus, sorry, yeah, so I'll write it like this: AC plus AD plus BC plus BD plus CD. Okay. Now, for a moment, let us just ignore this stuff. So what I mean by ignoring is this is strictly larger than A plus B plus C plus D. Now this actually, I thought this was, we are going in a good direction, because not only we have obtained a strict inequality which we had to show in the original problem. So they realize that there was no equality symbol here. So we had to show strict inequality. So, and this is in fact true. So this strict inequality came, and also the b plus c plus d also came. So perhaps this was important, and this was, we were going in the correct direction. So okay, so this is what I got. So okay, now what this showed was that if I multiply 2 on both sides on this thing, what I'm saying is, if I have that, this is 2, right? So I'll write it like this, and this is strictly greater than equal to, because we have shown it here. Yeah, this one. So I'll use this here. What I'll get is, yeah. So now what I have is this. So what I have is this. So this is a fact. This is not which this is. We have proven this till now. Doing this kind of arguments, we have proven that this is true. Okay, that's a good thing. Now the thing is, we want to show. Okay, so what we had to show was, we had to show this thing. So we want to show this thing. We want to show this thing, right? We wanted to show this thing. Now, my natural question was, okay, now how do I use these two conditions to arrive at my final answer? Now, here's the thing, because we want to show this, right? A sigma, yeah. So we want to show this, right? Now, the thing to realize is that our if I multiply by a on both sides of this inequality, okay, it would not change anything. So if I show that a times LHS, a times this term, and a is less than equal to a times this term, I will, if I show that, and I'll eventually, I can also, I basically get this condition for free. So now we can say that we can, so I'll write it like this, it suffices now, it suffices now to show. Now, why I'm multiplying a is, okay, I have to explain that. So here I have if you look at this fact which I have proven, I have a into b plus 2c plus 3d. So here also, if I had a into b plus 2c plus 3d, I could use this condition, right? So in order to use this thing which I have proven, I'll try to multiply, I'll multiply a on the thing which we have to show. Okay. So now it suffices now to show that sigma a square into a into b plus 2c plus 3d is less than, strictly less than 2 into a into sigma a into sigma ab. So if I show this, I basically get so what, let's organize our logic here. So if I show this, I get this thing for free. I get this. If I show this, I get this thing for free. And if I show this, I can backtrack and say that eventually my problem statement is true. You can just reverse the steps from here. If you go upward, you can just reverse the step, and you can show that eventually this is true. So now just our thing is, we have to prove this. Now let us use our fact. So the fact is that our a into b plus 2c plus 3d is less than 2 sigma ab. Okay, so what that means is that uh, if I show, okay, one thing is, now what we have to, now if you use this fact, what I have is sigma is okay. Let me just write this here. So what my fact was, this thing, right? This was a fact. Now let us multiply by sigma square on the LHS and RHS. Why? Because we have a sigma square here. So let us do that. So what we have is sigma square is a b plus 2c plus 3d is less than 2 sigma ab into sigma a square. Okay. So this is also another fact. Okay, this we have proven just now. Okay. Now, in fact, if I somehow, let's say this thing is this term is here. If I squeeze this in between these two terms, I am done. Because if I show, so what I'm trying to, I'll try to organize it here more. what I'm trying to say is, if I show that this thing here, okay, this thing here is greater than or is strictly larger than this thing, yeah, yeah, or if it's, yeah, or if it's greater than or equal to, in fact, so if this thing is greater than or equal to this thing, then I have that this thing is strictly larger than this thing, right? So that is what we wanted to show. I hope it makes sense. Let me repeat it. So what I'll show is this particular thing which I'm highlighting. If I show this part, this term here, this expression is greater than or equal to this term, then what I'm getting for free is that this term is actually strictly larger than this term. But that is what we wanted to eventually show, right? So that is my strategy now. That is my game plan. So that is and in fact, if we show that, we are done. So now it suffices to show 2a into sigma a into sigma ab is yeah, so it's okay. I'll write it like this. Yeah, 2 sigma ab into sigma a square is less than or equal to 2a sigma a into sigma ab. Let's see if this is true. So now I can cancel 2 on both sides, and in fact I can cancel ab on both sides, sigma ab on both sides. So what I'll have is a into a plus b plus c plus d should be greater than or equal to a square plus b square plus c square plus d square. So what I want to show is a square plus ab plus ac plus ad, okay, is a square plus b square plus c square plus d square. Okay, this is what I had to show. Now I can cancel a square on both sides. So this is what we have to show. Right, now this is actually quite trivial, because if you just notice the thing, this was the thing. If you just notice this, let me just copy this here. Yeah, so I'll copy. Okay, not copied the entire thing. Let me. Okay, so what we had in the problem statement was this. Now, if I have, let us see. So if I have AB, if I look at AB, now AB is greater than B square, because because okay, let's look at it this way. Since I have a greater than b, I can multiply b on both sides. I'll have ab is greater than b square. And also, since I have uh, what we say, I have a greater than equal to c, I have that ac is greater than c square. Also, a is greater than equal to d, so this implies that ad is greater than d square. So if you sum this one, and this one, what you'll get is that sigma, okay, no, not sigma. So ab plus ac plus ad is greater than or equal to b square plus c square plus d square. But that is what we had to show, right? So we are basically home free now. We are done. We are done with the problem. So that was what that was. Hopefully, uh, the idea and the step which I shown made sense to all of you guys, and hopefully it appealed to your intuition as well. So that was what I was trying. That was my purpose behind sharing this solution, so that this ideas actually refines our intuition. So as you can see, we motivated. I explained the motivation. I tried my best to explain the motivation behind each of my ideas, so that nothing looks very surprising, or like it's nothing looks like a magic trick or anything. So that, in fact, this actually the solution took a lot of time to develop as well. Okay, so with that, we are uh, done with this problem. This problem was actually, yeah, it was not that trivial. It was quite hard in my opinion. But yeah, but with, as you can see, if you argue, if your arguments are may like they are reasonable, and they make much sense, and they simplify things, then yes, you are eventually going in the right direction. Okay, so with that, I'll see you guys in the next show. Thank you.